welcome to today's maths class, and today we'll do fractions. Our learning objectives are fractions, equivalent fraction, simplifying fractions, kind of fractions, representation of fractions on number line, comparison of fractions, like and unlike fractions, addition and subtraction of fractions, and simplification. So first is fractions. Though you have learned about the fractions in your previous classes, let us recapitulate the concept in this class and learn further about it. You have learned that the fractions represent a part of whole. A part of whole is called fractions, where the part have to be equal and the whole may be the single object or the group of objects. For example, in a birthday party, Meera needs to divide a cake among 5 people, including herself. So each one get an equal share, equal part of the whole cake. Hence, you can say that each one will get one part out of 5 equal parts of the whole, which is written as 1 by 5. Now, if Meena gave her part of the cake to one of her friend, then that friend would have 2 part of the cake out of 5 equal part, which is written as 2 by 5. These numbers 1 by 5, 2 by 5, etc. represent fractions. They are also called unit fractions. In unit fraction, denominator is always 1. Next is writing fractions. A fraction is a number written as a quotient, one number divided by another. In the fraction 3 by 5, 3, the upper part, that is called numerator, and 5, the lower part, that is known as denominator. Next is some important observations. When an object is divided into equal parts, each part is called a fraction of the object. Each fraction has a numerator and a denominator. Next is exercise 4.1. Subject enrichment. Write the fraction for the shaded part of each of the following figure. In first one, how many equal parts are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 equal parts, out of that 1 is shaded. So that represents 1 by 9. Clear? Next is equivalent fractions. Equivalent fractions have the same values. For example, 1 by 3 and 2 by 6 are equivalent fractions. Look carefully at the following figure. In above figure shows that 1 by 3, 2 by 6 and 4 by 12 represent the same portion of the whole object. Here it is 1 by 3, it is represented 2 by 6 and 4 by 12. They represent same fraction or same portion of the whole. So 1 by 3, 2 by 6 and 4 by 12, they are called equivalent fractions. All these are equivalent fractions. It means that 1 by 3, that is equals to 2 by 6 equals to 4 by 12. Notice that 1 by 3, if here we multiply both numerator and denominator by 2, we will get 2 by 6. If we multiply both numerator and denominator by 4, we will get 4 by 12. And same 4 by 12 ko numerator and denominator both will get divided by 4, will get 1 by 3. And here 2 by 6, both numerator and denominator divided by 2 will get 1 by 3. So all these are equivalent fractions. Hence, the value of the fractions remaining unchanged if both the numerator and denominator are multiplied or divided by the same number. A upon B equals to A upon B. और मल्टीप्लाई कर लिया हमने न्यूमरेटर डिनोमिनेटर दोनों को C से, मीन्स A इंटू सी अपॉन B इंटू सी, एंड A upon B equals to A divided by C upon B divided by C, where C is not equals to 0. The above rules are useful for the conversion of equivalent fractions. Next is simplifying fractions. We often simplify the fractions by reducing it to lowest term. The fraction in its lowest term has a numerator and denominator that have no common factor except 1. Thus, reducing a fraction to a lowest term is done by converting it to simplest fraction equivalent to it. Next is fact file. When the answer to the mathematical problem is in the form of fractions, the result usually expressed in its lowest term. For example, 110 upon 165. So, we have to convert it to lowest term. First, we will divide it, both numerator and denominator by 5, will get 22 upon 33. Now, their common factor HCF, that is 11 से divide करेंगे, will get 2 by 3. That is the lowest form of that fractions. In practice, this is done by cancelling. Thus, 110 upon 165, that is equals to 2 by 3. In cancelling, we do the division in our mind. Clear? Now, we'll take an example. Reduce 120 upon 270 to its lowest term. Now, here what we have done? We have divided both the numerator and denominator by 10. So, we'll get 12 upon 27. Now, we'll divide by 3. Both the numerator and denominator will get 4 by 9. That is the lowest term of that given fractions. Clearly? Alternatively, using the prime factorization method. Prime factorization 120 का कर लिया and 270 का. Now, 2 से 2 cancel हो गया, 3 से 3, 5 से 5, 4 upon 9. That is the lowest term. Next, some important observations. Equivalent fractions have the same value. The fraction is simplified by reducing it to lowest term. Next is exercise 4.2. Subject enrichment. What set of equivalent fraction is shown by the shaded region in the following figure? In first one, 4 equal part, out of that 1 is shaded, so it will represent 1 by 4. Here 1, 2, 3, 4, total 8 equal part, out of that 2 are shaded. Here it will represent 2 by 8, and here it is representing 4 by 16. All these are equivalent fractions. Clear? So, practice all the questions of this exercise. Next is proper fractions, improper fractions and mixed numbers. What is proper fraction? In each of the fraction 4 by 5, 9 upon 11 and 13 upon 25, you notice that the numerator is less than denominator. So, they are the example of proper fraction. In proper fraction, the numerator is always less than denominator. So, all these are proper fractions. Clear? Next is improper fraction. Look at the following figure carefully. The above figure illustrates that 5 quarter or 5 by 4 can be written as 5 by 4, that is equals to 1 and 1 by 4, 1 plus 1 by 4. So, we write 1 and 1 by 4 or 1 plus 1 by 4 as 1 1 by 4. So, 5 by 4 is an example of improper fractions. In improper fractions, the numerator is always greater than denominator, which has the numerator greater than the denominator. So, it is an improper fractions. Next is fact file. That 9 by 9 is also an improper fractions because its numerator is the same as denominator. So, it is an improper fraction. Next is mixed numbers. 1 3 by 4 is an example of mixed number which contain an integral part and a fraction part. Integral part, this whole part, it is known as integral part, and next is fraction part 3 by 4. That is the fraction part. Clear? Next is expression of an improper fractions as a mixed number. To express an improper fractions as a mixed number, we divide the numerator by the denominator. The quotient obtained is the integral part and the remainder is the numerator of the fraction part. For example, 87 upon 13. So here we will divide 87 by 13. So we'll get 6 as the quotient. 9, that is the remainder, that will become the numerator, and the divisor, that will become our denominator. So mixed fraction में हो जाएगा 6 9 upon 13. Clear? Next is representation of fractions on a number line. Under article, you come across the pictorial representation of fractions. Look carefully at the following pictorial representation of fractions and the representation of fractions on number line given below them. Pictorial representation, it is 1 by 2, 1 by 4, 1 by 5. Next is representation on number line. Suppose we have to represent 1 by 2 fractions on a number line. So we will represent like this. This is 1 by 4 and this is 1 by 5. Clear? Next is how to denote fractions on a number line. Suppose you want to denote 7 by 9 on the number line. Follow the following step for it. Take a line segment AB of any unit length. Divide AB into 9 equal parts. Take 7 parts starting from the A to reach point P. Point P represents the fraction 7 by 9. So here we have to represent 7 by 9 on number line. So what we'll do? First we'll take a line segment of any length and divide into 9 equal parts. Denominator is 9, so 9 equal part, and we have to represent 7 by 9. So out of that 7 part, 1, 2, 3, 4, 5, 6, 7. So it will represent 7 by 9. Clear? Next is comparison of fractions. The position of 1 by 2, 1 by 4 and 1 by 5 on the number line indicate that 1 by 2 is greater than 1 by 4, that is greater than 1 by 5. But it is tedious to compare the fractions using number line. Hence the following general rule are observed to compare fractions. Rule number 1. If two fractions have the same denominator, then the larger numerator, the larger the fraction. For example, between 7 upon 10 and 9 upon 10, here the denominator is same, so we will compare the numerator. So, the fraction with the greater numerator will be greater, so 9 by 10 will be greater than 7 by 10. Because the denominator being same and the numerator 7 is greater than numerator 3. The numerator 9 is greater than numerator 7. Next is rule number 2. In contrast, the rule 1, the two fractions have the same numerator, then the larger denominator, the smaller the fractions. Between 5 by 9 and 5 by 7, here the numerator is same, so we will compare the denominator. The greater the denominator, the smaller the fractions. So 5 by 7 will be greater than 5 by 9. Because जिसका भी डिनोमिनेटर ज़्यादा होगा उसकी वैल्यू कम होगी. Next is rule number 3. If two fractions have different denominator and numerator, we convert the fractions into equivalent fractions having the same denominator or the numerator. Then apply either rule 1 or 2 as required. Now we'll take an example. Compare 3 by 4 and 5 by 7. So here denominator are different. So first we'll make the denominator equal. So for that 3 by 4, here we have multiplied both numerator and denominator 7. So we'll get 21 upon 28. Here 5 by 7. So what we have done? We have multiplied both the numerator and denominator 4. So we'll get 20 upon 28. Now denominator same, so we'll compare the numerator. The greater the numerator, the greater will be fraction. So 21 upon 28 will be greater than 20 upon 28. So 3 by 4 is greater than 5 by 7. So this way we can compare two fractions. Next is like and unlike fractions. Like fractions, fractions having the same denominator are called like fractions. For example, 7 by 8, 6 by 8, 4 by 8 and 9 by 8. All are having same denominator, so they are like fractions. Next is unlike fractions. Fractions with the different denominator are called unlike fractions. Like 5 by 6, 7 by 9, 4 by 7 and 1 by 2 are all unlike fractions. Next is some important observations. Fractions are either proper, improper or mixed. If two fractions have the same denominator, then the larger numerator, the larger fraction. If two fractions have the same numerator, then the larger the denominator, the smaller the fractions. Clear? Next is exercise 4.3. Subject enrichment. Which of the following is proper fractions, improper fractions or mixed fractions? First one, 2 1 by 3. It have two parts, one integral and one fraction part. So it is a mixed fractions. Mixed fraction. Clear? So you have to practice all the questions of this exercise. Next is addition and subtraction of a fraction with the same denominator. Illustration 1. Figures show that 2 by 7 plus 4 by 7. Denominator are same, so what we'll do? We will simply add the numerator and write the common denominator below. So 2 plus 4, that is 6 upon 7. Clear? That will show 6 by 7. Like here. 1 by 7, 1 by 7, that will represent 2 by 7 and that will represent 4 by 7. Clear? So total कर देंगे तो क्या आ जाएगा 6 by 7. Clear? Hence, the general rule for the addition and subtraction of fractions will be the same denominator r. For addition, add the numerator and not change the denominator. For subtraction, find the difference of the numerator and do not change the denominator. और for addition, addition के लिए क्या हो जाएगा? A upon C plus B upon C, that is equals to A plus B upon C. And for subtraction, A upon C minus B upon C, that is equals to A minus B upon C, where A, B and C are whole number and C is not equals to 0. Next is addition and subtraction of fractions with the different denominator. Now here, when denominator are different, how will we add and subtract fractions? So go through the following illustration carefully. Illustration 1. It will represent 1 by 3 and 1 by 4. Now if we have to add them together, so denominator are now same. So first we'll make the denominator same. So 1 by 3, we have multiplied both numerator and denominator 4. So we'll get 4 by 12. 1 by 4, so what we have done? We have multiplied both numerator and denominator 3, so we'll get 3 by 12. Now we add them together, that is equals to 7 by 12. Clear? Notice that 1 by 3 and 1 by 4 are converted to 4 by 12 and 3 upon 12. The fraction with the same denominator. Next is addition and subtraction of mixed numbers. To understand how to add and subtract mixed number, buy carefully to following example. 4. Given below. Evaluate. In this example, we have to add mixed number. 1 5 by 9 plus 3 8 by 15. We have to add them together. So what we'll do? We will add the whole part different and fraction part different. So 1 plus 3, that is integral or whole part, and fraction part, that is 5 by 9 plus 8 upon 15. So 4 हो जाएगा, and here what we have done? We have taken the LCM of 9 and 15, that is 45. So we written the LCM here, 45. Now first fraction, that is 5 by 9, So what we have done, 45 divided by 9, that is equals to 5. So 5 into 5, 25. Next, 45 divided by 15, that is equals to 3. 3 into 8, that is 24. Add them together. So 4 plus 49 upon 45. Clear? 4 plus 1, 5. 4 upon 45. That will be our answer. Clear? Next is exercise 4.4. Computational thinking. Evaluate the following and give your answers in the simple form. So 21 upon 50, 17 upon 50 plus 12 upon 50. All these are like fractions, but the denominator are same. So simply we will add the numerator. That is 21 plus 17 plus 12. (50 upon 50), that is equals to 1. That will be our answer, like this. Clear? So practice all the questions of this exercise. Next is simplification. Order क्या होगा? Bracket, then of, then division, multiplication, addition and subtraction. The operation involved in simplifying an arithmetic expression is ranked according to the order of simplification. The order is popularly known as Bodmer's rule. Bracket are 4 kinds given below according to their order of simplification. First, bar of vinculum. This is the bar of vinculum. Then parenthesis or the round bracket or the small bracket or first bracket. This one. Then braces or curly bracket or second bracket, then big bracket or we can say square bracket or third bracket. Clear? Now we'll take an example. Simplify 21 minus 5 plus 17 minus 0 minus 5, bracket closed. So 21 minus, सबसे पहले हम कौन सा ब्रैकेट, ब्रैकेट के अंदर कोई ब्रैकेट है तो सबसे पहले उसको सॉल्व करेंगे. सो फर्स्ट विल सॉल्व दिस ब्रैकेट. सो हो जाएगा 17 माइनस 5 प्लस 17, 10 माइनस 5, दैट इज 5. सो 10 माइनस 5. नेक्स्ट इज 21 माइनस 5 प्लस, now we'll solve this, 10 minus 5, that is again 5. So 17 minus 5, that is equals to 12. So 21 minus 5 plus 12. So 12 and 5 को add करेंगे, that is minus 17. 21 minus 17, that is equals to 4. That is our answer. Next is exercise 4.5. Critical thinking. Simplify the following. In first one, so पहले हम किसको सॉल्व किए? फर्स्ट विल सॉल्व द बार, दिस वन. सो विल राइट 12 माइनस बिग ब्रैकेट 9 माइनस देन कर्ली ब्रैकेट 15 देन माइनस 12 minus 9 minus 5, that is 4. -12 9 minus 15, 12 minus 4, that is equals to 8. So I'll write now 15 minus 8, that is equals to 7. So ये जाएगा 12 minus 2, 12 minus 2, that is equals to 10. So our answer is 10. Clear? Next is, let's recall. Take the correct option. If 3 by 4 is the equivalent to x by 20, then find the value of x. So 3 by 4 is equals to x by 20. So we'll cross multiply here. So x equals to हो जाएगा x equals to 20 into 3 upon 4. So x equals to 15. That means A is our correct option here. Clear? So here we end the chapter. I hope you understand it well. Now you have to practice it.